Hello everyone, I am Muaz Siddiqui, your physics mentor, and today students we are going to start a very interesting topic from physics, that is vectors. Why I am just starting with vectors before touching any of the other topic from grade 11 or grade 12 physics? The reason is vector is going to be used throughout your grade 11, grade 12 physics. Whenever we will deal with any physical quantity which is a vector, students, we are going to go through this concept and this concept will be required. Okay, so we will start with vectors. Before starting with vectors, I want to discuss one point, that is a very important proverb or a very important thing, that is mathematics is the language of physics. If you want to be good in numericals, especially in physics, your basic mathematics and your vectors should be very strong. Okay, so students, today we will make this concept vectors super easy, point number one, and throughout our grade 11 and grade 12 it will help us to make the numericals easy for us, and our approach will be totally different. We will also learn many short tricks. That short tricks will help us to solve the numerical in the shortest possible time. Okay, so let's start one of the important topic from physics, that is vectors. So students, if I ask what is a vector quantity, so in grade 9 you have heard that like any physical quantity can be put into two categories. Number one, a scalar quantity or a vector quantity. Okay, so scalar are simply those quantities which have only magnitude. They obey ordinary law of algebra. Okay, but what are vector quantities? In grade 9 we have studied that any physical quantity which have number one magnitude, number second direction, means any physical quantity which have magnitude as well as direction is a vector quantity. Okay, this much we have studied. Okay sir, but what is different when we come to grade 11? Okay, how we can more elaborate a vector? So just understand this with the help of an example. Let's go to grade 10. Okay, in grade 10 we have studied electric current. What we have studied? Electric current. Do you remember? We have studied what? Electric current. Yes sir, we remember electric current. ठीक है ना? So what electric current it is basically? Now if we consider a wire, inside the wire we have free electrons, and let's say electrons are moving, drifting towards the left side of the conductor. Make thing simple as of now. The electrons are moving towards the left side of the conductor. So what we say, the electric current will be towards right side of the conductor, which is let's say 10 ampere for example. Now if you focus on this, I equals 10 ampere with an arrow, means with the direction. So here you can see student that we have electric current. This 10 ampere is the magnitude. Yes sir, this is the magnitude, we understand, and this arrow is the direction of the current, opposite to the direction of flow of electrons. So by the definition of vector, what we can say? A physical quantity having magnitude, yes sir, having direction, yes sir. So electric current is a vector quantity, but the point is electric current is not a vector quantity. Why it is not a vector quantity? Although it has both magnitude as well as direction, there is one more trick, there is one more point need to be considered when we give a tag to a physical quantity. It is a vector. And what is that? The point is electric current should obey vector laws. It should obey vector laws. Sir, what are vector laws? We will study in like as we move further, we will study what are vector laws. But the point is, for any physical quantity to be a vector, we should have magnitude, we have direction, but one more thing we have to add, that is it should obey vector laws. So for any physical quantity to be a vector, three things: magnitude, direction, as well as it obey vector laws. In case of electric current, it does not obey vector laws. So that's why we put electric current in the category of scalar, although electric current have both magnitude as well as direction. I think my point is very clear to all of you. Okay, can we move further? Yes. So let's begin to our next topic, or to our next subtopic of this vector, that is a representation of a vector. How we will represent a vector? How we will represent a physical quantity? We can say by looking at it, like this is a vector or this is a scalar. So when we move to the representation of a vector is represented by the help of an arrow. By the help of an arrow. So what is an arrow? How we can make an arrow? A straight line with some direction. Okay. So this is an arrow. Okay, so any vector quantity can be represented by the help of an arrow, student. Okay, so for this arrow, this point is called tail and this point is called head. This point is called tail and this point is called head of the arrow. Okay, and we have one more thing, the length of the arrow, and this is very important. You have to put focus here, all of you student, that this length of the arrow. Why this is important? Because the length of the arrow is directly proportional to the magnitude of the vector. Magnitude of the vector. We will understand it more by the help of an example. First, just take an example of speed and velocity. Okay, we have two physical quantities, speed and velocity. Speed is a scalar, we know from our grade 9th class, and velocity is a vector quantity. Okay sir, we know. So for speed, what we will do, if we use the letter V to represent speed, and we will use the letter V also, same letter, to represent velocity. But if to the letter, if we put an arrow above it, means V with a arrow on it, means it is representing velocity. But only V, then we will consider it to be speed. Okay, one thing. Second thing, if let's say we have this velocity vector and if we make modulus of it, means two lines, one in the front and one after the letter. So this thing represent modulus. Modulus means that it represent the magnitude of the vector. Magnitude of the vector. Magnitude of the vector. So whenever you see a letter with an arrow and we have this modulus, means this is x vector modulus, x vector magnitude, x vector magnitude. Okay, so let's say we have two vectors. One is vector x and the other vector is y. Okay, we have two vectors, x vector, y vector. Now you can clearly notice here the length of this x is less than the length of vector y. So we can say x vector magnitude is less than y vector magnitude. Okay, so length have its own importance. If the length is more, the magnitude of the vector will be more. If the length is less, the magnitude of the vector will be less. Hope so students, you get my point. And like we can move further. The next topic we are going to discuss here is unit vector. What we are going to discuss? Unit vector. The name itself, unit vector. Unit means one. Next we will discuss unit vector. So what is a unit vector? A vector students, a vector whose magnitude is one, is unit, or is one or unit. What does it mean? For example, let's say a vector A is given. A vector A is given, and it is given that vector A is a unit vector. So we can say vector A magnitude is going to be 1. Vector A magnitude is going to be 1. Okay. So what is a unit vector? A vector whose magnitude is 1. Okay. So this is a very simple thing. A vector whose magnitude is going to be 1 is a unit vector. Okay. So now, like, how to find the magnitude of a vector? Okay. So we understand a unit vector will be a vector whose magnitude is 1. Before going to the magnitude, we will discuss one more thing here. We know the space around us. Okay. The space around us have 3 dimensions. We have the x-axis, we have the y-axis, and we have the z-axis. Okay. Let's take an example of this classroom itself. Okay. So if you see in this classroom, if we start with this line, okay, if we start with this line, so this is our x-axis, okay student, and this line is y-axis, and we move, if you come out from this plane outside, this is our z-axis. Okay, so we have 3 coordinates. All of you know that we have x, y and z. If I make all these 3 coordinates, let's say this is x-axis, this one is y-axis, and this one is z-axis. Okay, so we are dealing with unit vectors. Okay, vector magnitude is 1, but if the magnitude is 1, what is the use of unit vector? To represent direction. Means, sir, let's say we want to represent positive x-axis. So this is the positive x-axis. So the positive x-axis will be represented by I cap. Sir, what is this cap? Cap. Okay. Previously we have written I vector, but this time you are writing I cap. So whenever, instead of using a arrow, if we are making a cap, it means it represent a unit vector, means the letter it's itself a unit vector, means I is a unit vector. Okay. So I cap means I is a unit vector and it represents positive x-axis. Positive x-axis. Are you getting my point, students? Can we move further? Yes. Okay. Now what we have? Y-axis. For y-axis we use J cap. Cap means unit vector. So what J cap represent? A direction. Which direction? Positive y-axis. Positive y-axis. Okay. Now we will move to next unit vector, which is our K cap. Which is our K cap. So what is K cap? K cap is a unit vector whose magnitude is 1. But it represents the direction. And which direction is represent? It represents positive z-axis. It represents what? Positive z-axis. One more thing we can note down here, students, all of you in your notebook, that all these three, I cap, J cap and K cap, these all are 3 unit vectors. So their magnitude is going to be 1. Their magnitude is going to be 1. Okay. So we have to remember this I cap, J cap and K cap. So first thing what we studied till now, number 1, unit vectors, a vector whose magnitude is 1. To identify a unit vector, there is generally a cap over the letter. Third point, what we have? Unit vector represent a direction. And there are 3 standard direction which we have discussed. Number 1, x-axis will be represented by I cap, y-axis will be represented by J cap, and z-axis will be represented by K cap. Now, I will take you to the next point, next level, where we will get real questions which were asked in NEET exam as well as IIT exam. Okay. So for that, we have to first understand how to find the magnitude of a vector. Okay. So we will start with next topic, that is how to find magnitude of a vector. In the next class, we will discuss how to find magnitude of a vector. Then we will do some numericals. The next concept we are going to start, how to make a unit vector of a particular vector, which is very interesting. Again, the question came in the school exam as well as board exams. School board exam as well as competitive exams. The next we will discuss how to frame a unit vector, how to frame a vector by using unit vector and its magnitude. Again, important numerical point of view. So my classes will be concept delivering, next numerical. Concept, numerical. In this way we will proceed. Brick by brick we will make a wall. Step by step we will move further. And definitely, if you break a complex problem into small chunks of steps or concept wise distribution, the thing will be easy and we will definitely make our physics understanding more clear and numerical approach more clear and profound. That's all from my side, and hope so we will in the next class we will start with the numericals. Thanks. I am your physics mentor, Moaz sir. Thanks a lot.